Picture your grandmother suddenly becoming a baby again. Not metaphorically, but literally reversing her biological age, cells transforming back to their infant state. Sound impossible, right? Well, there's a creature the size of your pinky nail doing exactly this right now in our oceans. And scientists just figured out how it works. This isn't science fiction. In 2024, researchers made human cells 30 years younger in a lab. The cells of a 50-year-old became like those of a 20-year-old. We're not just talking about slowing aging anymore. We're talking about reversing it. The creature behind this revolution? A tiny jellyfish called Turritopsis dohrnii, barely 4.5 millimeters across. When most animals reproduce and age, they die. This jellyfish? It basically hits the reset button and becomes a baby again. Scientists have watched it do this over and over in labs. Theoretically, it could live forever. Here's what happens. When this jellyfish faces stress, injury, or just gets old, it doesn't die. Instead, it sinks to the ocean floor and transforms. Its bell collapses, tentacles retract, and then, this is where it gets weird, its adult cells literally forget what they are. Muscle cells, nerve cells, digestive cells, they all transform back into stem cells. Then the jellyfish rebuilds itself as a polyp, basically its baby form. From there, it grows up again, and again, and again. The mechanism that shouldn't exist. Most of us learned in biology class that cell specialization is a one-way street. Once a cell becomes a muscle cell or a brain cell, that's it. Game over. This jellyfish basically said, nope, to that fundamental rule of biology. The process is called transdifferentiation. I know, fancy word, but here's what it actually means. Imagine if your skin cells could suddenly decide to become heart cells, or your liver cells could transform into neurons, without going through stem cells first. That's what this jellyfish does, except with its entire body, all at once. In a lab, scientists have triggered this transformation using different stressors. Starvation works. So does physical damage. Temperature shocks do it too. The jellyfish's response? Guess I'll just become a baby again. Within days, a mature jellyfish completely restructures itself into a polyp colony. The really mind-blowing part is that about 20 to 40% of adult jellyfish skip some stages entirely and go straight from adult to polyp. What makes this even more remarkable is the speed. We're not talking about gradual changes over months or years. The whole transformation takes just a few days. The jellyfish goes from adult to infant in less time than it takes you to get over a cold. Now, here's where things get interesting for us humans. This jellyfish isn't using some exotic biological machinery that only exists in jellyfish. It's using cellular mechanisms that exist in most animals, including humans. It's just using them in a way nobody thought was possible. Cracking the genetic code. In 2022, Spanish scientists from the University of Oviedo did something nobody had done before. They sequenced the entire genome of the immortal jellyfish. Then, and this was the clever part, they compared it to a close relative, Turritopsis rubra, which ages and dies like a normal animal. The differences they found were stunning. The immortal jellyfish has twice as many copies of genes that repair and protect DNA. Think of it like having twice as many mechanics in a garage. When something breaks, there are more hands available to fix it. These extra gene copies produce more repair proteins, which means the jellyfish can fix cellular damage much more efficiently than its mortal cousin. But it wasn't just about quantity. The immortal jellyfish also had specific mutations in genes that maintain telomeres. You know how shoelaces have those plastic tips that keep them from fraying? Telomeres are like that, but for chromosomes. Every time a cell divides, these tips get a bit shorter. When they get too short, the cell stops dividing and eventually dies. The immortal jellyfish found a way around this problem. The research team found variants in genes like GLI3, which help stem cells decide what to become. The immortal jellyfish has twice as many copies of this gene, and they're all active during the transformation process. It's like having extra managers in a factory reorganization. More coordination, better results. Actually, let me correct myself there. It's not just like having extra managers. The jellyfish also has enhanced genes for dealing with oxidative stress, basically cellular rust. You know how metal rusts when exposed to oxygen? Similar things happen in our cells. The immortal jellyfish has superior anti-rust protection, from jellyfish to human cells. So we got this jellyfish that can reverse aging. Cool party trick, but what does it mean for humans? Well, that's where things get really exciting. In 2023, a team at Harvard Medical School led by David Sinclair achieved something remarkable. They made old human cells young again. Not just healthier, not just more energetic, actually younger at the molecular level. They reversed the aging clock by decades. Here's how they did it. Remember those specialized cells I mentioned earlier? The ones that supposedly can't change what they are? Turns out there's a set of genes called Yamanaka factors that can make adult cells forget their specialization. These factors basically wipe the cell's memory clean, turning it back into a stem cell. The problem with Yamanaka factors is that they work too well. If you fully activate them, cells become so young they turn into tumors. Cancer, basically. So Sinclair's team had to figure out how to partially activate these factors, enough to make cells younger, but not so much that they lose control. They developed chemical cocktails that could do this. 6 different combinations that could take old human cells and make them young again. The cell's gene expression patterns reverted to those of young cells. Their epigenetic age, basically the cellular clock, went backwards, all in less than a week. Think about what this means. We're not talking about making cells act younger. We're talking about actually reversing their biological age. It's like taking a 50-year-old car and not just giving it a new paint job, but actually turning it back into the car it was 30 years ago. Same car, just younger. The chemistry of youth. The breakthrough wasn't just that they could make cells younger. It was that they could do it with chemicals instead of gene therapy. Until this discovery, the only way to reverse aging in cells was through complex genetic manipulation. You had to insert genes into cells using viruses. Expensive, complicated, and risky. But chemicals? That changes everything. Chemicals can be put in pills. They can be injected. They can potentially be delivered to specific organs or tissues. Suddenly, the possibility of reversing aging goes from a complex medical procedure to something as simple as taking medication. The Harvard team tested their chemical cocktails on different types of human cells: skin cells, blood cells, nerve cells. The results were consistent. The cocktails reversed markers of aging across cell types. The cells didn't just look younger under a microscope. They acted younger. They divided more readily. They repaired damage more efficiently. They expressed genes like young cells do. One fascinating aspect is how these chemicals work together. It's not one magic molecule. Actually, that's something I should emphasize. There's no single fountain of youth chemical. The cocktails contain multiple compounds that work synergistically. Each chemical plays a specific role in the reprogramming process. Some open up the chromatin structure, making genes more accessible. Others activate specific transcription factors. Still others suppress pathways that maintain cell identity. David Sinclair described it as resetting the cell's software without changing its hardware. The DNA stays the same, but the instructions for how to read that DNA, the epigenetic information, gets restored to a younger state. Real-world applications getting closer. The leap from laboratory success to actual medical treatments is happening faster than anyone expected. In 2024, researchers at the MD Anderson Cancer Center made another breakthrough. They found a single molecule that could restore muscle strength, stimulate brain cell growth, and reduce inflammation in elderly mice. This molecule, called TEC, works differently from Sinclair's cocktails. It increases production of telomerase, the enzyme that rebuilds those protective caps on chromosomes I mentioned earlier. In old mice, equivalent to 75-year-old humans, TAC treatment led to remarkable improvements. New neurons formed in the memory center of the brain. Cognitive performance improved. Muscle function that had deteriorated with age was restored. The mice didn't just feel better or move better. Their tissues were literally younger at the cellular level. Inflammatory markers decreased. Metabolic function improved. The treatment even reversed age-related muscle loss, not by building new muscle, but by restoring existing muscle fibers to a younger state. Similar results are appearing in studies worldwide. Researchers in Barcelona showed that partial reprogramming with Yamanaka factors could protect neurons from Alzheimer's disease. Teams in California demonstrated that cellular reprogramming could restore vision in mice with glaucoma. Each study adds another piece to the puzzle of how we can reverse aging in living organisms. The timeline for human applications is accelerating too. Sinclair predicts that age reversal pills could be available within 10 years. Clinical trials for some approaches are already being planned. After successful results reversing blindness in monkeys, gene therapy trials in humans are on the horizon. But here's something interesting and honestly a bit concerning. We're moving so fast that regulatory frameworks are struggling to keep up. How do you test an anti-aging drug? What endpoints do you measure? How long do trials need to run? These aren't simple questions. Traditional drug trials test specific diseases. Aging isn't classified as a disease. Yet, what this means for you. Let's get personal for a moment. What does all this mean for someone reading this right now? Well, if you're in your 40s or 50s, you might be among the first generation to benefit from these technologies. If you're younger, you might never experience aging the way previous generations did. I'm not saying everyone will live to 200 next year, or even in 10 years, but the scientific consensus is shifting. Aging is no longer seen as inevitable. It's increasingly viewed as a biological process that can be modified, slowed, and potentially reversed. The first applications will likely be targeted. Maybe eye treatments to reverse age-related vision loss, or skin treatments to reverse visible aging, joint treatments for arthritis. These focused applications will pave the way for more comprehensive approaches. Think about what this could mean for quality of life. It's not just about living longer. It's about being healthy longer. Imagine being 80 with the energy and health of a 50-year-old. Or 100 with the vitality of someone decades younger. This isn't about extending the period of decline. It's about extending the period of health. The economic implications are staggering too. If people can remain healthy and productive for decades longer, retirement ages will need rethinking. Healthcare costs could plummet if we're preventing age-related diseases rather than treating them. Society might need to completely restructure how we think about careers, relationships, and life planning. But let's not get ahead of ourselves. These technologies are still in development. We don't know all the risks yet. Long-term effects need study, and there are legitimate concerns about access and equity. Will these treatments be available to everyone, or just the wealthy? How will society handle potentially massive disparities in lifespan? The weird thing about aging is that nobody really knew what it was until recently. Sure, we could see the effects, wrinkles, gray hair, slower movements. But what actually causes aging at the cellular level? That was a mystery. until scientists studying our immortal jellyfish friend started connecting the dots. Turns out, aging isn't just one thing going wrong. It's more like a symphony where all the instruments gradually go out of tune. DNA damage accumulates. Proteins misfold. Cellular garbage piles up. Communication between cells breaks down. The immortal jellyfish? It basically retunes the entire orchestra. The epigenetic revolution. Here's where things get technical, but stick with me. Your DNA is like a massive instruction manual for building and running your body. But having the instructions isn't enough. You need to know which pages to read and when. That's what epigenetics does. It's the system that tells cells which genes to turn on and off. As we age, this system gets messy. Imagine someone going through your instruction manual with a marker, randomly highlighting some parts and crossing out others. Eventually, your cells can't read the instructions properly anymore. They forget how to do their jobs efficiently. The immortal jellyfish in those Harvard experiments, they're essentially cleaning up those marks, restoring the manual to its original, pristine state. When researchers looked at rejuvenated cells, they found that thousands of genes had returned to youthful expression patterns. Genes that had been silenced with age were active again. Genes that had become hyperactive with age calmed down. One researcher described it to me. Wait, actually, I read about a researcher who compared it to restoring an old painting. You're not adding new paint. You're carefully removing the grime and damage that accumulated over decades, revealing the original masterpiece underneath. The jellyfish does this naturally during its transformation. When it reverts to a polyp, its cells undergo massive epigenetic reprogramming. Methylation patterns, basically chemical tags on DNA, get completely reorganized. The cellular memory of being an adult jellyfish gets wiped clean, replaced with the instructions for being young again. Beyond the jellyfish, other immortal creatures. The immortal jellyfish isn't alone in its defiance of aging. Scientists have discovered several other organisms that seem to have cracked the code of extreme longevity or regeneration. Take the hydra, a tiny freshwater creature that looks like a living tube with tentacles. These creatures show no signs of aging, ever. Scientists have kept them in labs for decades, and they just keep going, showing the same vigor as day one. Their secret? About 20% of their body is made up of stem cells that constantly renew all their tissues. Every cell in their body gets replaced every few weeks. Then there's the axolotl, that perpetually smiling salamander from Mexico. Chop off its leg, it grows back. Damage its heart, it regenerates. Injure its brain or spinal cord. No problem, it'll fix those too. The axolotl can regenerate entire limbs, organs, even parts of its brain, without forming scar tissue. And it does this throughout its entire life. Naked mole rats are another piece of the puzzle. These wrinkly, underground creatures live up to 30 years, 10 times longer than similar-sized rodents. They're immune to cancer, feel no pain from acid, and their bodies don't deteriorate with age like other mammals. Their cells are resistant to becoming cancerous, and they maintain their fertility throughout their entire lives. What do all these creatures have in common? They've all found different ways to maintain or restore cellular youth. The jellyfish resets itself. The hydra constantly rebuilds. The axolotl regenerates. The naked mole rat resists damage. Each strategy offers insights into how we might extend human health span. The human trial's beginning. In 2024, the first cautious steps toward human age reversal began. Not with pills or injections, but with gene therapy targeting specific organs. The eyes were chosen first, partly because they're isolated from the rest of the body, making treatment safer, and partly because age-related vision loss affects millions. The results have been remarkable. In early trials, patients with age-related macular degeneration, the leading cause of blindness in older adults, showed significant improvement. Not just halted progression, but actual reversal of damage. Patients who hadn't been able to read for years could suddenly see well enough to read large print. Some regained the ability to recognize faces. The treatment uses a modified virus to deliver 3 of the 4 Yamanaka factors to cells in the retina. Why only 3? Because using all 4 causes cells to lose their identity completely, potentially forming tumors. With 3 factors, cells rejuvenate while remaining functionalized cells. One patient, a 74-year-old former teacher, described the experience. It wasn't sudden. Over about 6 weeks, things just got clearer. First, I noticed colors seemed brighter. Then I realized I could read the subtitles on the TV again. Her retinal cells showed markers of being 15 to 20 years younger after treatment. However, and this is important, not everyone responded equally. About 30% of patients showed dramatic improvement, 40% showed moderate improvement, and 30% showed little change. Scientists are still figuring out why responses vary. Genetics probably plays a role. So does the extent of existing damage. But they're learning with each patient. The cellular cleanup crew. One fascinating discovery from jellyfish research involves cellular senescence. Senescent cells are like retired workers who won't leave the office. They stop dividing but don't die, and they release inflammatory signals that damage nearby healthy cells. As we age, these zombie cells accumulate. The immortal jellyfish has an elegant solution. During its transformation, it completely clears out senescent cells. Every single one gets either rejuvenated or eliminated. It's like a company doing a complete staff reorganization, keeping only productive workers. Scientists have developed drugs called senolytics that can selectively kill senescent cells in humans. Early trials show promising results. Patients report more energy, better joint function, improved skin appearance. One trial participant mentioned feeling like someone turned the clock back 5 years after just 3 months of treatment. But here's the thing about senescent cells. They're not entirely bad. They play important roles in wound healing and preventing cancer. Eliminating them completely could cause problems. The trick is finding the right balance, removing the harmful ones while keeping the beneficial ones. The jellyfish seems to have figured this out. During its transformation, it doesn't just blindly eliminate all senescent cells. It appears to reprogram them, turning harmful senescent cells back into healthy, functional cells. That's much more elegant than just killing them off. The metabolism connection. Metabolism, how our bodies process energy, is another key piece of the aging puzzle. As we get older, our metabolism becomes less efficient. Cells produce less energy, accumulate more waste, and generally function like an old car engine that needs a tune-up. The immortal jellyfish undergoes a complete metabolic reset during transformation. Its energy production systems get rebuilt from scratch. Mitochondria, the cellular power plants, are renewed. Metabolic pathways that have become sluggish spring back to life. Recent research from the University of Southern California found something intriguing. Brief periods of metabolic stress, like fasting, can trigger some of the same rejuvenation pathways the jellyfish uses. Not the complete transformation, obviously, but partial activation of cellular renewal programs. This led to development of fasting-mimicking diets that can activate cellular rejuvenation without the difficulty of actual fasting. Participants in trials showed reduced biological age markers, improved metabolic health, and enhanced stem cell production. It's not as dramatic as what the jellyfish does, but it's a start. Actually, I need to clarify something. These diets don't make you younger overnight. The changes are gradual, occurring over months, but they demonstrate that we can influence our biological age through relatively simple interventions. You don't need genetic engineering or exotic chemicals. Sometimes, just changing when and how you eat can activate rejuvenation pathways. The brain challenge. The brain presents unique challenges for age reversal. Unlike other organs, you can't just replace or completely reprogram brain cells without potentially losing memories and personality. The brain isn't just tissue, it's the repository of who we are. The immortal jellyfish sidesteps this problem entirely. When it transforms, its simple nervous system essentially dissolves and rebuilds. It doesn't have complex memories to preserve. But for humans, any brain rejuvenation needs to be much more careful. Scientists are exploring partial reprogramming approaches for the brain. The goal is to rejuvenate neurons without disrupting their connections or stored information. Early experiments in mice are encouraging. Old mice treated with rejuvenation factors showed improved memory and learning ability without losing existing memories. One approach involves targeting support cells in the brain called glia rather than neurons themselves. These cells can be more safely rejuvenated, and when they're younger, they better support the neurons. It's like renovating the infrastructure of a city without disturbing the residents. Another strategy focuses on clearing out protein aggregates, clumps of misfolded proteins that accumulate in aging brains and contribute to diseases like Alzheimer's. The jellyfish's transformation completely clears such aggregates. Researchers are developing drugs that can trigger similar cleanup processes in human brains. The unexpected mental benefits. Here's something nobody expected. Cellular rejuvenation appears to affect mental health too. Patients in age reversal trials often report improvements in mood, reduced anxiety, and better cognitive clarity. This isn't just feeling better because they're healthier. Brain scans show actual changes in neurotransmitter production and neural connectivity. One trial participant, a 68-year-old engineer, described it. The mental fog I'd accepted as normal just lifted. Problems I've been struggling with at work suddenly seemed manageable again. My wife says I'm more like my younger self, not just physically, but mentally and emotionally too. This makes sense when you think about it. The brain is part of the body. If cellular aging affects the brain, then reversing that aging should improve brain function. But the extent of mental and emotional improvements has surprised even researchers. Depression and anxiety, increasingly common with age, might partially result from cellular aging in the brain. If that's true, age reversal therapies could revolutionize mental health treatment for older adults. Instead of treating symptoms with antidepressants, we might address the underlying cellular causes. The safety question. Let's address the elephant in the room. Is it safe to reverse cellular aging? The honest answer is, we don't fully know yet. The jellyfish has been doing it for millions of years, but humans are much more complex organisms. The biggest concern is cancer. Many of the pathways involved in cellular rejuvenation are also involved in cancer development. Push cells too hard to become younger, and they might become cancerous instead. It's like overclocking a computer. Push too hard, and things can go wrong. That's why current approaches are so cautious. Partial reprogramming, targeted treatments, careful monitoring. Nobody's trying to turn a 70-year-old into a 20-year-old overnight. The goal is gradual, controlled rejuvenation. There are other risks too. Immune system disruption is possible. So is metabolic dysfunction. Some treatments might work too well in some tissues and not enough in others, creating imbalances. One researcher compared it to renovating a house. You need to make sure all the systems still work together properly. The jellyfish avoids these problems through its complete transformation. Everything resets at once, maintaining balance. Humans need more targeted approaches, which is technically harder but probably safer. Long-term effects are another unknown. The immortal jellyfish has been cycling through rejuvenation for eons. Humans doing it for the first time? We're in uncharted territory. Will rejuvenated cells age normally afterwards? Will they need periodic touch-ups? Will there be unexpected consequences years down the line? So here we are. We've got a jellyfish that lives forever, scientists making old cells young again, and the first humans getting age reversal treatments. What happens next? The short answer: things are about to get really interesting. The long answer involves some predictions that sound like science fiction but are grounded in current research. By 2035, we'll likely see the first widely available age reversal treatments. Not full-body rejuvenation, but targeted therapies for specific conditions. Eye treatments for macular degeneration, skin treatments that go deeper than cosmetic fixes, joint therapies that actually restore cartilage rather than just managing pain. These will be the gateway drugs, so to speak, of the anti-aging revolution. The economic earthquake. Nobody's really talking about this yet, but age reversal is going to completely upend our economy. Think about it. Our entire financial system is built on the assumption that people work for 40 to 45 years, then retire and live maybe 20 to 30 more years. What happens when people can stay healthy and productive for 80, 100, maybe 150 years? Pension systems will collapse. Or rather, they'll need complete restructuring. The concept of retirement at 65 will seem as outdated as retiring at 45 does now. Insurance companies are already quietly freaking out about this. How do you price life insurance when death becomes increasingly optional? But it's not all chaos. Imagine the economic boost from having experienced workers stay productive for decades longer. The 80-year-old engineer with 60 years of experience who still has the energy and mental clarity of someone half their age. The accumulated knowledge and skills that won't be lost to retirement. One economist I read about estimates that extending healthy lifespan by just 10 years could add trillions to the global economy. Not from people working longer necessarily, but from reduced healthcare costs and increased productivity during what are currently the declining years. The job market will transform too. Career changes at 70 or 80 will become normal. Why stick with one profession for 100 years when you could have 3 or 4 different careers? Education will become lifelong in a literal sense. Universities are already planning for students who might return for new degrees every few decades. The social revolution. Relationships are going to get complicated. Marriage, till death do us part, takes on new meaning when death might be 150 years away. Will we see more serial monogamy? Relationship contracts with renewal clauses? The divorce lawyers are going to have a field day. Actually, some sociologists predict the opposite might happen. With less pressure from limited time, people might make better relationship choices. No more rushing to settle down because the biological clock is ticking. When you've got centuries ahead, you can afford to wait for the right person. Family structures will change dramatically. 5 or 6 generations alive at the same time will be normal. Great-great-great-grandparents who look and act like they're in their 40s. The traditional passage of wealth and property from one generation to the next, that'll need rethinking when the older generation isn't going anywhere. Here's a weird thought. What happens to coming of age when your parents and grandparents look almost as young as you? The traditional markers of adulthood and maturity will need redefining. Society might develop new rituals and milestones that aren't based on biological aging. Population concerns are real too. If people stop dying from age-related causes but keep having children, even at reduced rates, we're looking at massive population growth. Some experts suggest reproduction might become regulated. You want to live to 200? Fine, but you can only have 1 or 2 children. Others think birth rates will naturally decline as lifespans extend. The access problem. Let's be honest about something. These treatments won't be cheap, at least not initially. The first age reversal therapies will likely cost hundreds of thousands, maybe millions of dollars. The wealthy will get younger while the poor continue aging normally. The inequality gap won't just be about money anymore. It'll be about time itself. This terrifies ethicists. Imagine a world where billionaires live for centuries while regular people get the standard 80 to 90 years. The concentration of wealth and power could become extreme. The same individuals controlling resources not just for decades, but for centuries. However, there's reason for optimism. Technology tends to become cheaper over time. The first cell phones cost thousands and were the size of bricks. Now, smartphones that are infinitely more powerful cost a few $100s. The same pattern will likely apply to age reversal treatments. Some countries are already discussing universal access to longevity treatments as a human right. The argument goes, if we can prevent suffering and death from aging, don't we have a moral obligation to make it available to everyone? It's the same logic behind universal health care, just taken to its logical conclusion. The jellyfish, ironically, might help here. It uses natural biological processes that, once understood, could be triggered relatively cheaply. We're not talking about exotic materials or complex machinery. The chemical cocktails being developed could eventually be mass-produced like any other pharmaceutical. The identity crisis. Who are you if you live for 200 years? This isn't a philosophical question. It's a practical one. Our sense of self is tied to our life stages. Childhood, adolescence, young adulthood, middle age, old age. What happens when those stages stretch out or disappear entirely? Some psychologists worry about mental stagnation. Will people become set in their ways after living for centuries? Or will the ability to physically rejuvenate also refresh mental flexibility? The jellyfish doesn't have this problem. It literally starts fresh each time. Humans will need to consciously work to stay mentally young. There's also the memory question. Can the human brain store 200 years of memories? Some researchers think we'll need technological assistance, external memory storage that interfaces with our biological brains. Others believe the brain's plasticity will adapt, keeping important memories while letting trivial ones fade. The concept of legacy changes too. Why rush to make your mark when you've got centuries ahead? Some predict this will lead to longer-term thinking about environmental and social issues. Why trash the planet when you'll personally have to live with the consequences for the next 150 years? The technical challenges ahead. Making cells younger in a petri dish is one thing. Rejuvenating an entire living human is vastly more complex. Different organs age at different rates. Your liver might be biologically 50 while your heart is 70. Synchronizing rejuvenation across all systems is like conducting an orchestra where every section is playing at a different tempo. The delivery problem is huge. How do you get rejuvenation factors to every cell in the body? The immortal jellyfish has it easy. It's tiny and can transform all at once. Humans have around 37 trillion cells. Current approaches use modified viruses or nanoparticles, but these don't reach every cell equally. Timing matters too. Rejuvenate too quickly, and you risk cellular chaos. Too slowly, and some cells might age while others rejuvenate, creating dangerous imbalances. The jellyfish takes days to transform. Humans might need months or years of gradual treatment. Then there's the brain problem I mentioned earlier. We can't just reset the brain like the jellyfish does. Every neuron, every connection potentially holds important information. Researchers are exploring ways to rejuvenate brain support structures while leaving neural networks intact. It's like renovating a library while making sure none of the books get damaged or misplaced. The near-term reality. Okay, let's come back to Earth. What can you actually expect in the next 10 to 15 years? Full immortality? No. But significant life extension? Absolutely. The first commercial treatments will likely be preventative. Drugs that slow aging before it causes major damage. Think of them as supervitamins that actually work at the cellular level. You might start taking them in your 40s or 50s to maintain cellular health. Organ-specific treatments will come next. Injections that rejuvenate your liver, kidneys, or heart. These might be done every 5 to 10 years, like getting your car serviced. The goal won't be to make organs teenage young, just to reverse a decade or two of aging. Cosmetic applications will probably lead the market. Not just surface treatments, but deep cellular rejuvenation of skin. The beauty industry is pouring billions into this research. Ironic that vanity might fund the technologies that eventually reverse aging throughout the body. Gene therapies will become more common but remain expensive. These will target specific age-related conditions rather than aging itself. Reversing genetic predispositions to Alzheimer's, cardiovascular disease, or certain cancers. Prevention through rejuvenation rather than treatment after disease develops. The real breakthrough, systemic, full-body age reversal is probably 20 to 30 years away for the general public. But incremental improvements will add up. Someone who's 50 today might be biologically 45 in 10 years and still 45 in 20 years. Not immortality, but a significant extension of healthy life. Learning from nature. The immortal jellyfish isn't the only teacher. Researchers are studying everything from bristlecone pines that live for 5,000 years to bowhead whales that reach 200. Each species that defies normal aging patterns offers clues. Tortoises, for instance, show negligible senescence. They don't really age in the traditional sense. A 100-year-old tortoise is as likely to survive another year as a 10-year-old tortoise. Their cells are incredibly resistant to stress and damage. Scientists are trying to understand and replicate these protective mechanisms. Some bats live 10 times longer than similar-sized mammals. Their secret appears to be extremely efficient DNA repair mechanisms and unique immune systems that control inflammation without suppressing necessary immune responses. These insights are leading to new anti-inflammatory therapies that might slow human aging. Plants offer different lessons. Some trees are essentially immortal, living for millennia. They compartmentalize damage, constantly grow new tissue, and can survive losing large portions of their structure. While we can't copy plant strategies directly, understanding their principles helps develop new approaches to regeneration. The ethical dilemma. Should we even do this? That's a question that keeps bioethicists up at night. Death has been fundamental to human existence since, well, forever. What happens to human meaning and purpose without the urgency that mortality provides? Some argue that death gives life meaning. Without an endpoint, experiences might lose their preciousness. Why cherish moments when you have infinite moments ahead? But others counter that this is like saying food only tastes good because we'll eventually starve. More life doesn't necessarily mean less meaning. Religious perspectives vary wildly. Some see age reversal as playing God, interfering with natural order. Others view it as using God-given intelligence to reduce suffering. The jellyfish, after all, evolved its immortality naturally. Are we wrong to learn from creation? There's also the environmental argument. More people living longer means more resource consumption. Unless we dramatically change how we live, extended lifespans could accelerate environmental destruction. Counterargument. People who personally experience the long-term consequences might be more motivated to protect the planet. The natural argument comes up a lot. Aging is natural, so we shouldn't interfere. But so are diseases we routinely cure. So is death in childbirth, which we prevent. We've been interfering with nature since we discovered fire. The question isn't whether to interfere, but how and to what extent. Your personal timeline. Here's what you should actually care about. What does this mean for you, specifically, right now? If you're in your 20s or 30s, you'll likely have access to significant life extension technologies by middle age. Plan accordingly. Your career might span 80 years instead of 40. Your retirement planning needs rethinking. Maybe skip that tattoo you'll have to live with for 150 years. In your 40s or 50s, you're in the sweet spot for first-generation treatments. Not experimental guinea pig territory, but early enough to benefit from emerging therapies. Start taking cellular health seriously now. Exercise, diet, stress management. These aren't just about feeling good. They're about maintaining your cells in a state that can be more easily rejuvenated later. 60s or older. Don't despair. The next 10 to 15 years will see treatments specifically targeting age-related decline. You might not get the full reversal younger people will eventually access, but significant improvements in health span are likely. The goal is to stay healthy long enough to benefit from better treatments as they emerge. Everyone should be paying attention to the research, not the hype. There's plenty of that, but the actual science. Understanding what's possible helps you make informed decisions about health and life planning. The immortal future. That tiny jellyfish floating in the ocean started something big. Really big. We're not just talking about living longer. We're talking about redefining what it means to be human. The comparison isn't perfect, obviously. We're not jellyfish. We can't just sink to the ocean floor and transform into babies. But we're learning to achieve similar results through different means. Chemical cocktails, gene therapies, cellular reprogramming, multiple paths to the same destination. In 50 years, aging might be viewed like polio is today, a problem previous generations faced that we've largely solved. Death might become a choice rather than an inevitability. Not for everyone, not immediately, but eventually. The jellyfish reminds us that biological immortality isn't impossible. It exists in nature. We're just learning to translate it into something that works for complex mammals like ourselves. Every breakthrough brings us closer to cracking the code. Whether that's a good thing or not, well, that's for us to decide. The science is advancing regardless. The jellyfish will keep transforming, cycling between adult and youth, demonstrating that the boundary between young and old isn't as fixed as we thought. We're standing at the threshold of the most significant transformation in human history. Not space colonization, not artificial intelligence, the ability to reverse aging itself, to choose how long we live, to potentially live forever. All because scientists decided to study a tiny jellyfish. Wild, right?